many grams of excess reagent were consumed. The target now for this stoichiometry problem, make the want your excess reagent. We want to know the vanadium starting from the limiting reagent 100. We'll divide, ratio, multiply, where in this problem we start with limiting and make the want the excess reagent. In our first conversion factor, we'll start with the 1 mole of phosphorus and put it over its molar mass of 31 grams per mole. Sorry, that says grams. 1 mole of phosphorus has a molar mass of 31 grams. Sorry for the sloppy. We want over given is the stoichiometric ratio. Remember, we want the excess reagent from the limiting. The want over given. We want to know vanadium. Its coefficient of 3 will go on the top. Given the moles of phosphorus, its coefficient will go on the bottom. We have a 3/4 stoichiometric ratio. In the last step, we want to bring it out to grams for our excess reagent. Knowing that that's our target, we'll use the molar mass in step 3. The molar mass of vanadium, we looked up from up above, it's 51 grams in every 1 mole. So I wrote 51 grams of vanadium over 1 mole of vanadium. Start with the limiting reagent and work toward the excess reagent. I'll type in 100, divide that by 31, times 3 divided by 4, there's our ratio, and multiply by 51. When I hit enter, 123.39 grams of vanadium was used. I'm not done with my problem. It asked me how much was left over unused. I go back to that original story problem. See the beginning mass of 175? Let me write that in the side margin here. 175 grams of vanadium is what we started with. What we just determined was how much vanadium was consumed, used up during our chemical change. We found that to be 123.39. I want to know the difference. If I started with 175 and used 123.39, I am going to subtract 175 minus 123.39, our answer to the stoichiometry problem. And that difference will tell us the mass of the excess reagent left over, wasted, unused, sitting in the beaker at the bottom. And I will report that. Where can I put it? How about right under here for used? I'll report that difference, 51.61. And that's grams of vanadium. And there is my answer to part C. Let me turn off the video for a moment, give you time to digest this, and then we'll move on to part 2.
We have in front of us our worksheet in the hours. Let me begin by asking you to make sure we're on the same page where it's saying objective 3, identify new limiting reagent and a reaction to calculate the maximum maximum amount of product produced and the amount of excess reagent or left over at the end. There's a side 1 and a side 2. I just want to be sure we're all on the same page, looking at the first side. I'll read for us the first of our story problems. It reads, vanadium 4 phosphide is produced from its constituent elements. The constituents of vanadium and the elements that it's made up of. To begin with, I want to point at our product and think about charges and then producing. Vanadium is the symbol V, which carries a +4, the Roman numeral calculus. Phosphide is the symbol P, and it's a -3. When I crisscross, I get P3, P4. The elements that it's built of would be vanadium and phosphide.